and the heading is mass and weight. Now we've done this in grade 8. What is mass? Yes, mass is the amount of matter. Amount of matter, and we usually measure it in kilograms. I think in grade 5, 6, and 7 they taught you that matter, all matter occupies space, all right, and has mass. Ne? Yeah, mass or weight. All right. So at this point, we've done a little bit of the kinetic theory. We know all matter is made up out of particles, and these particles are called atoms. The atoms of different substances differ. In other words, an atom of carbon is different to an atom of aluminium. All right? And therefore, we find that even though we have the same volume of a substance, if I have 1 cubic meter of a foamolite block, and I have 1 cubic meter of a block of wood, which one's going to be heavier? The wood. Even though they have the same volume, their masses can differ. All right. So here we have the definition for mass, the amount of matter in a body. Can you remember what instrument do we use to measure mass with? A balance of some kind. We get different types in the laboratory. These ones are the older types. A triple beam balance, a lever arm balance, a top pan balance, a beam balance, or an electronic balance. Yeah. That is the one that with a spring that stretches to measure force. All right, people, so the instrument that we use to measure mass is a balance, or you can say a mass meter. But balance is the correct word. Don't use the word scale, because the word scale actually refers to the division. For example, on a graph, what is the scale that you used? 2, 4, 6, 8, 10. Do you understand? All right. Don't use the word scale. It is a balance that we use to measure mass. Now, mass goes together with weight. We are all here on the earth. We don't float around in outer space, because if we were in outer space, we would have mass, but we wouldn't have weight. Because we are here on earth, we find that if I was hanging from a tree or if I jumped from the roof, I will go down. All right? Why do I go down? We know that the earth has a force on my body, and we call this gravity. So gravity is the force that attracts objects towards the center of the earth. The amount of gravity depends on the amount of mass, because gravity has an effect of 10 newtons for every 1 kilogram of mass. All right, so the greater the mass, the greater the force of gravity acting on your body. If we flew from here to the moon also has gravity. But the gravity of the moon is less than that of the earth. It's approximately 1/6 of that of the earth. So, if I had a mass of 60 kilograms here on earth, and I flew up to the moon, what would my mass be? 60 kilograms. On earth, what would my weight be? 600 Newton. And on the moon? Approximately? 1/6, 100 Newton. Eh? 1/6 Newton. 600 Newton? 1/6 is 100. Yeah. Yes? Okay. People, the greater the mass, the greater the gravity. When there is a resulting force, that object will accelerate. So, if I jump out of an aeroplane and I don't have a parachute and there is no air friction, is there a resulting force? So I'm going to float up there. There is a resulting force. I am going to fall faster and faster and faster and faster. But because we have an atmosphere, and if I jumped out of the aeroplane with a parachute, what happens? As I fall faster, 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 what happens to the friction? It becomes more. And we reach a point where the force of gravity is cancelled by opposing frictional forces. And what do? I will fall with constant velocity. All right. Yes. Yes, yes. When you start falling with constant velocity with a parachute that has opened, then it is terminal velocity. You will reach terminal velocity if you don't have a parachute, but it's just going to be very fast. And you will hurt yourself when you land or kill yourself when you land. With a parachute, the speed is slow enough for you to be, when you land or you roll, to absorb your momentum, to convert it to zero. No? Okay. On the Earth, force of gravity will cause all matter to accelerate at 10 meters per second squared, because for 1 kilogram, it will exert a force of 10 Newton. Okay? So what would the acceleration be? We know F is equal to m times A. So if F is 10 and mass is 1, what is acceleration? 10. All right, so the force of gravity makes any object accelerate at 10 meters per second squared. Listen to me. I'm standing on the top of a very high building, and I have a marble in my hand. The moment I jump off the building, ignore air friction, and I let the marble go, which of us will hit the ground first? Why? Gravity accelerates everything at 10 meters per second. People, weight, we said, is the force of attraction between an object and the Earth. That is why we have weight. In actual fact, the Earth has a big mass. It exerts an attractive force on you, your body, or any object that has mass. But the object also exerts an attractive force on the Earth. But because our masses are relatively small in relation to that of the Earth, our force is so small we can ignore it. But it does actually exist. All right. So, if the weight of an object is known, we can determine the mass by dividing the weight with 10. Okay. Now, the gravitational field strength is the force of gravity per unit mass. Okay? Gravitational field strength is the force of gravity, 10 Newton, per unit mass, kilogram. On the moon, that's approximately 1.6 Newton per kilogram. Because of the force being 10 Newton per kilogram, we find that gravitational acceleration, the acceleration caused by this force, is equal to 10 meters per second squared. And any object falling close to the Earth will fall at a rate of 10 meters per second. All right. We can determine weight by multiplying mass by G. Still busy with objects that are falling. When an object falls under the influence of gravitational acceleration and there are no opposing frictional forces, the object is in a state of free fall. No air resistance, falling with constant acceleration. Now, usually here on Earth, there is air friction when the object falls. So initially, an object will accelerate towards the Earth due to its weight. The friction when you are moving slowly is very little. It's so little we can ignore it. So then we will say that there, for the first part, there isn't any opposing forces. You are in a state of free fall. But as you go faster and faster, in other words, as you gain speed, we find that the resistance, the friction increases. All right? There is still a resulting force making you go faster and faster, but that force makes that the value for the acceleration becomes less and less and less and less until eventually the acceleration is zero. No, eventually as the speed increases, the friction becomes more until the weight of the object is balanced by air friction. And at that point, there is no resulting force. So the object will fall with constant velocity, and we call this maximum constant velocity is the terminal velocity of the object. This brings us to something called inertia. And the best illustration of inertia is, for example, I have a little bottle with water, and I put it on the table under a piece of paper, and I am a magician. Why did it stand still? Due to the inertia of this bottle. It means an object wants to keep standing still or continue moving with constant velocity unless, yes, but that's Newton 1. All right, now inertia is just simply the ability of an object to stay at rest if it is at rest, or to keep on moving if it is moving. Yeah. Okay, so the ability of an object to maintain its state of rest, in other words, to stand still if it's standing still, or state of uniform motion, if it's traveling at constant speed, it wants to keep traveling. All right? In a straight line, the inertia of the body is directly proportional to the mass. The larger the mass, the more the inertia. Before you go, in the car, no seatbelt. Traveling at 120 kilometers per hour, you slam on the brakes. What happens? Why do you want to go forward? You are traveling at 120 kilometers per hour. Your body wants to keep on traveling at 120 kilometers per hour.
Shoprite is your home of low prices this Christmas with unforgettable savings on everything you need. Stock up this festive season with great deals like 1.5 kilos of real good frozen mixed chicken portions, only $49.99, and 700 mils of all gold tomato sauce, just $26.99. Don't miss out on unforgettable savings at the home of low prices this Christmas. Only at Shoprite. Lower prices you can trust. Always.
As we go and you have questions, you must ask, all right? Don't let it just go by. All right, so exercise 1 on page 153. What is the size of the force a person must use to lift a box of mass 5 kilogram? If you are on Earth, we have to multiply with 10. That will give us 50 Newton. 2. A television camera has a mass on Earth of 5 kilogram. The gravitational field strength of the Earth is 10 Newton per kilogram and the Moon is 1.6 Newton per kilogram. What is the mass of the camera on the Moon? Does the mass change? No, the amount of matter didn't change. We didn't lose a lens and a shutter along the way. Are you with me? Okay, the mass remains the same. And then what is the weight on the Moon? Well, the weight on the Moon is mass times 1.6 because the gravity is 1.6 Newton per kilogram, and that gives me 8. Number 2, exercise 2. 1. A bus full of passengers needs more force to turn at a corner than when it is empty. Explain the statement in terms of inertia. Now, inertia was a new concept that we did. And we said, what is inertia? I used the example of the water bottle. Inertia is the ability of an object to stay at rest, if it is at rest, or if it is moving with uniform motion in a straight line, it wants to keep on doing that. That is why you go flying out of your seat if you don't have a seat belt and you slam on the brakes. Okay? So, why do we require a greater force when the bus is full? Well, when the bus is full, it has a greater inertia because inertia is directly proportional to the mass. So, to make it change direction, we have to overcome that inertia, and that will require a greater force. And then B, state and explain the relationship between mass and inertia. Mass is directly proportional to inertia. The bigger the mass, the more the inertia. The Afrikaans word for inertia is traagheidsmassa. It actually says exactly what it does. It doesn't want to start moving, or if it is moving, it doesn't want to change moving. No? Okay. C. In Namibia, we have to wear seat belts wherever we are traveling in a car. Explain the importance of wearing the seat belt. Well, the seat belt helps to overcome your body's inertia if we stop suddenly. Yes? Okay, the seat belt helps to overcome your inertia, or in terms of F delta T equal to M delta V, the seat belt allows the force to apply for a longer period of time.
It will lower the time.
No,
in which a force takes place.
not lowering the time. It will increase the time. You stretch against the seat belt. Okay, allowing the force to become smaller.
The force will decrease when you increase the length of time.
Yes.
So your force will decrease.
Yes. All right. Which of the following statements is true? Less mass, objects have more weight. That's rubbish. 2. More massive objects have more inertia. That's true. More massive objects have less inertia. That's rubbish. And D. Moving objects have more inertia than stationary ones. No, they have more momentum, but their inertia is proportional to the mass. So that's false. So the correct one is B. 2B. Number 3. If A and B were two objects with masses 125 and 180 kilograms respectively, then will both have the same inertia? No, we've just said inertia is directly proportional to the mass. So the one with the bigger mass, the 180 kilogram one, will have more inertia than the 125 kilogram one. So now we have to do the check your progress. That is there on page 156. The first question. Potatoes are packed into 4 different sized sacks as shown. Which sack holds the greatest mass? Well, obviously D, because it's 20 kilograms. Yes, D. Then B1. When offloading trucks containing sacks of potatoes, the workers will often toss the sacks to one another to speed up offloading. Which of the sacks of potatoes would be more difficult to catch? The 20 kilogram one, D. Yes, give a reason for your answer. Well, it is number 2. Which arrow shows the direction of the weight of the block? People, where does weight always go? Vertically down. Just have a look at this. If I have an incline and I have an object on that incline, yes, there is a force if I'm pulling it there and a force in the opposite direction. Yes, there is a force perpendicular to the surface and the surface has a force back on it. But weight is a force that works from the center of the object vertically down. No matter where you are. Alright, your weight always goes from the center of the object vertically down. There's another concept that we actually should do with this part. It's not in your textbooks. They talk about something called the center of mass. Yeah, it's got to do with that. We'll do that when we get to that part, okay? But the center of mass is the point within an object over there from where the weight works vertically down. Do you understand, people? The center of mass is the point within an object through which the weight works vertically down. You with me? Okay. So, the correct choice there by number 2 is D, not C. No. Is C going vertically down? No. Weight always goes vertically down. If you can't figure it out, you take a piece of string that hangs with a weight on it. That one always goes vertically down. No. Alright, then, number 3, in which one of the following units can mass be measured? Mass is measured in kilograms, so it is B. Number 4, the diagram shows a beam balance. What does this type of balance measure? It measures mass. B. Number 5, 2 objects balance each other as shown. Which physical factor would be the same for the 2 objects? Choose one. In this case, it would be the mass B. Number 6. The diagram below shows 4 objects that are made of the same material. Which object has a mass that is different from the others?
Because the volume needs to be the same. Yes. But if it's not, it's that one.
People, can you see between A and B? B is going to have a smaller mass. No. Between C and D, C will have the smaller mass. Okay? So, which one would have a mass that is different from all the others? It would be, well, you can look at it in terms of the mass of D is going to be different to that of, actually you have to go and work out the volume. Yeah, this is actually a silly question. Yeah, so we would have to look at the volume for A. It is 4 times 4 times 1. Volume of B is 4 times 2 times 1. Volume of C is 2 times 2 times 2. 2 times 2 times 2. And the volume of D is going to be 1 times 1 times 8. 1 times 1 times 8. Let's quickly have a look. 4 times 4 is 16. 8. 2 times 2 is 4 times 2 is 8. 1 times 1 times 1 is 8. Which one will have a different mass? A. That's quite unusual, the question. Okay. People, why? Density is mass per unit volume. If they are made from the same material, the one that has the bigger volume will be heavier. All right. So that is what we've worked out. We had to work out the volume. And the one with the biggest volume is going to be the heaviest. Yeah. Okay. Number 7. The lever arm balance has 2 scales. That's on the picture that they've got there. If the object to be measured has a small mass, we use the upper scale. Oh, okay. But they don't give us the calibration. Oh, there's the upper and the lower scale. Oh, okay. 80, 70, 60, and the other one is 400, 300. Okay. So the increment differs. On the one, it is 1 unit, and on the other, it is going to be 10. Yes. So if the object has a small mass, we will use the upper scale, the one that has got the 1 increment. No. For heavier objects, we will use the lower scale. Okay, so look at diagram A. The upper scale, what is the value of each small division? It is going to be 1 gram. Yes. And then 2, what is the reading on the scale for the lighter mass? In other words, the reading on A, it is 66 grams. And then B, look at diagram B, the lower scale, what is the value of each small division? It is going to be 10 grams. And then what is the reading on the scale for the heavier mass? It is 310 grams. Is that correct? Yes. That is the check your progress. Hang net gou 'n tak? Nee, is net water. Ek het water ingegooi, dit is 'n lens, want dit buig die lig. Dis maar al, dis nie baie skoon nie, ek sien. Moet dit nie drink nie. Seker so iets ook. Okay, did you have another worksheet? No. Okay. Oh, that was with the chemistry. All right. I want to carry on with density. Yes. Okay, so ons kan hier aangaan, hè? Okay, grade 10s. I want to carry on with density. That's the next unit, unit 8. Now, when we start off with a new concept, density, there's always a definition. What is the definition for density? It is the mass per unit volume. The unit in which we measure density, if we look at the formula, it is mass divided by volume. The unit for mass is a gram and volume is a cubic centimeter. Or we can work with kilogram per cubic meter. Now, we can write this unit gram per centimeter cubed, or we can write this gram per centimeter cubed. It means the same thing. It's the same with the meters per second, ne? Yes, I prefer the top one. It doesn't matter. It's easier to type than that one. It doesn't matter. It's fine. Okay, so take note then of the way in which the unit can be written. In an object that has a very high density, if we look at it in terms of the kinetic theory, it means there are many particles packed together. In our class, we have, how many kids are you? 2, 4, 6, 8, 10, 12 kids. If I pushed 50 into this class, then the density would be very high. Are you